Oh, yes, guys, welcome back to PMS School. Today we are still continuing with our sixth part of the introductory work, that's trigonometrical ratios of acute and obtuse angles. In the previous video, we looked at the acute angles specifically, that's 0 degrees, 30 degrees, 45, 60, and 90 degrees. And if you remember very well in our previous video, sine of when we reach 90 degrees, sine of an angle was actually the cos of the complementary angle, or the cos of its complement. Complementary angles add up to 90 degrees, so its complement is if the angle is theta, the complement is going to be 90 minus theta. But now for this case, today we are going to look at obtuse, whereby obtuse angles, for the case of obtuse angles, we are going to see that we are going to have, if sine of an angle, say theta, is going to be given by sine of its supplement, of which the supplement, supplementary angles add up to angles that add up to 180 degrees. So the supplement of an angle, say theta, is 180 degrees minus theta. That's a supplement. And so, but for this case, it's going to remain, if sine of theta is going to be sine of 180 minus theta, which is its supplement, but with appropriate sign. Because now for this case of obtuse, we can't use right angle triangle like we did in our previous videos for 45 and for 90 degrees. It was only for 30 and 60 that we used an equilateral triangle of both sides too. So now for this case, we're going to see this, and before we I want you to be well acquainted with what I've written down here. For obtuse angles, I told you in our previous video, acute angles lie here, obtuse angles lie between 90 and 180, reflex 180 to 160, acute 0 to 90 degrees. So for this case, we are looking at angles that lie between 90 and 180 degrees, of which they measure up to that second quadrant. And now we have to realize this. I want you to come to this now. You see this simple, I can say, a way that I've used for you to master which of these trig ratios are positive in these quadrants. Here you find that all, that's what I'm saying, follow this, all sans teachers confused. Just you take the first letters here, all, here sine, here tan, t standing for tan, then here c standing for cos. Whereby in this first quadrant, 0 to 90 degrees, you have all the trig ratios, sine, cosine, and tangent are all positive. In this second quadrant, only sine, where we have put sans, s standing for sine. Sine is the only positive trig ratio here, whereas cos and tan are negative. Here, where you see teachers, t standing for tan, only tan is positive. That means sine and cosine are negative here. The fourth quadrant, where you see confused, c standing for cos. Cos is the only positive trig ratio here, whereby the sine and tan are negative in this quadrant. And that's what would help us now to find. Now if you have sine of theta, remember I told you that here sine is going to remain sine of its supplement, which is 180 minus theta, but with the appropriate sign. So you have to take note that you have to see that here we had sine theta and sine 180 minus theta, which means that here actually we see that here we have only sine positive. Second quadrant has only sine being positive. That's why you see I have positive sine 180 minus theta. Now for the case of cosine, cosine is in which quadrant? It's in the fourth quadrant, and that's where it's only trig ratio which is positive. That means tan and sine are negative. But now for 180 minus theta, it lies in this quadrant where sine is the only positive trig ratio. So we realize that since it's cos, it's going to be cos of the supplement, but with negative. Why? Because cos is negative in this quadrant. Remember here it's only sine that is positive, so cos is going to be negative. The same goes to tan. In that quadrant, tan is negative. It's only sign positive. The second quadrant where there's 180 degrees minus theta. That this angle. You've gone theta. The remaining angle here is 180 minus theta, since all of this from here to here is 180. So that means we are also going to have tan negative there. So now let's go into the examples to help us get more onto these trig ratios, as we even summarize that of acute, and that's in our previous video and the one for today. Let's go through some examples. Let's show that, number one, show that cos squared 30 degrees plus cos 60 degrees times sine 30 degrees is given by 1. In mathematics, once you're told to show something, you need to show that one side, you need to start from one side and prove at that side, one side will lead to the other side. It means if you start with this left hand side, you must manipulate this left hand side until it's 1. That's how you show that this actually is equal to 1. So let's go through our solution. What is this? This is our easiest one, where we can start. You can't start from 1 to come here. It's literally impossible. So unless you're going to do a lot of manipulations. So here is the one. Let's start with our left hand side. It's given by cos squared 30 degrees plus cos 60 degrees times sine 30 degrees. Now we can split this. Cos 30 squared is just the same as cos 30 times cos 30 degrees plus cos 60 degrees times sine 30 degrees. That's interpreting that. And in our previous video, we realized that we looked at cos of 30. Cos of 30 was a root of 3 out of 2. Please, if you have not well acquainted with this, you need to go and check our previous video. That's 0.6a, which can show you how we derived trig ratios of 30, 60, 90, 45, and 0 as well. You need to check our previous video. In our previous video, we know this. We even gave a table that summarizes them here. Let me show you. Here we have angle, sine, cos, tan. So cos of 30 is actually root 3 out of 2. And that's why I'm putting root 3 out of 2. So you need to go and check that out in case you didn't watch. Now cos 30 is still root 3 out of 2. Plus cos 60. In our previous video, we saw that cos 60 was half. Times even sine 30 was half. So now we see that now concept of our surds. I think was it almost our fourth part of the introductory work. Root of 3 times root 3 will come back to 3. Out of 2 times 2 will be 4. If you are multiplying root of the same numbers, just comes back to that number. Plus 1 half times half is 1 out of 4. If you realize, this is going to be 1. 3 out of 4 plus 1 out of 4 is 1. Therefore we have cos squared 30 plus cos 60 sine 30 is equals to 1 as required. So that's the first example that we have handled today. Let's go to the next one. Number 2. Write each of the following as a trig ratio of an acute angle. Write each the following as a trigonometrical ratio of an acute angle. You need to know what an acute angle is. Lies between 0 to 90 degrees. So we need to check. Let me say our first one can be sine of 155 degrees. B, let's say cos of 140 degrees. C, let's say tan of 130 degrees and 30 degrees. So now let's start with our a straight away. Solution: we have sine of 155 degrees. So you go and draw, be some side work here. You draw your quadrants. 155 will actually be 90 plus how many? That's 155 is actually 90 plus the plus, let's just subtract plus minus 180. What will that be? I think it's going to be 180 minus 145 to get this angle. It's going to come up to there. 90 plus some angle into the second quadrant. So that's actually, I think, 675. 90 plus 675 will give us 155. So that means here we have 180 minus this. 180 minus this angle, that's 155 degrees. That means we're going to remain 25 here. 25 degrees. So that means actually we have sine 155 degrees is going to be given by this. Just a concept of what we looked at today, that's obtuse. It has entered in this, and this quadrant, what is positive? Sine is positive, so it's positive. Since it's sine, we use that sine of 180 degrees minus 155 degrees, which we looked at here. It's 25, positive sine of 25 degrees. And if you press in a calc, positive sine of 25 is going to be equal to the sine of 155 degrees. Let's go to B. Cos of 140 degrees, which is going to be, still it's going to enter into that quadrant there. So we have measured 140 degrees, so this angle will be 180 minus 140, which is actually 40 degrees. So it's going to be here. Cos is negative here. Remember I said here all are positive. Sine is positive here, tan is positive here, and cos is positive here. So that means here cos and tan are negative, so it's going to be negative cos of 180 degrees minus 140 degrees, which is actually negative cosine of 40 degrees. See that 25 and 40 are already acute angles. So we go to C, which is tan of 130 degrees, and we draw that. We see what it is. 130 will enter there because it's beyond 90 degrees. 90 is here, and you draw that. It's up to that point. So if this is 130 degrees, that means here it's actually, I think, 50 degrees if you subtract that. So we're going to have, here we have tan. Tan is negative, so it's negative tan of 180 degrees minus 130 degrees, which is equal to negative tan of 50 degrees. Okay, so you realize that all these angles have been expressed as a trig ratio of acute angles. 25 is within 0 to between 0 and 90, 40 between 0 and 90, and as well 50 between 0 and 90. So we realize that we were using the concept we looked at before, that for a trig ratio of an obtuse angle is actually that same trig ratio of the or trig ratio of the supplementary angle, but with the appropriate sign. So sine is the same as sine, but the complement of 155 is, supplement of 155 is 25. Supplementary angles add up to 180 degrees. So now we go to another group of questions. Let me say number 3. If sine of 35 degrees is given by 0.5736, write down the values of, let's say, let me look at 2. Let me say it's A sine 145 degrees and B cos 125 degrees. Let's look at the solution, how we can handle that. We have A, which is sine 45 145 degrees. 145. So here sine 145 degrees. Let us check how we can express that in terms of 35. So that means we already have sine 35 given. That means we have to create sine 35 somewhere, but we are going to say use the same concept that we have been using. We have seen 145 is an obtuse angle, is low beyond, between 190 and 180 degrees. So you first draw that. We have here 145 enters there inside. We say that angle is 145. Now what will remain here? I think it's 35 degrees. And since it's sine, that actually means in this quadrant we have only sine positive from what I gave before. So it's going to be plus sine of the supplementary angle, which is going to be positive sine of 35 degrees. And positive sine of 35 degrees is already given, which is 0.5736. We look at B, which is cos of 125 degrees. If you draw 125 there, 100, I think it enters inside there beyond 90. So we're going to have that 125 degrees. So that means here will remain something. That's, I think, 55. Yeah, 55 degrees. So it's going to be positive. Here we have cos is cos, but which is negative, because in this quadrant we have it's only cos that's negative. We are using that concept that cos of a supplement of an obtuse angle is given of the appropriate sign of that same cos, or the appropriate sign with cos of the supplementary angle, which is actually 180 degrees minus 125 degrees, which is equal to negative cos of 55 degrees. But we don't yet have 35 degrees. So what do? We have here between 90, we know 55. If you see this angle, if we realize that is 90 plus 35, that gave us 125 here. That means if here is 55 and here is 125, how do we get this angle here? We're going to realize that here we first consider this is 90. We'll see that here remains 35. 90 minus 55 will give us that 35 degrees, because this angle here is 90 degrees. If you realize that, so we have 35 here, but now how do we get sine of that 35? Because we need sine of 35, which the value is already given. So we can just complete that. We also complete that. Okay, let's give this side, that's 90, and there is also what? 90. We have just joined that line now to make a right angle triangle. So here let's give here x, let's also say here is y, and here z. You're given insides. So what does it mean here? We are just giving these letters to help us know that the different the trig ratios that are really existing for this angle and that angle 35. So here, if here is x, that means that length is the same as its length. There is also x. If here is y, that length is also what? Y. Okay. So now for that case, we can see. How about our cos? Now we check that cos of 55 degrees. From here, cos of 55 degrees. Okay. It's given by what? Cos, remember our thing, SOHCAHTOA in our previous video. This one, sine is the same, is equals to opposite of hypotenuse. Cos is adjacent out of hypotenuse. Tan is opposite of adjacent. SOHCAHTOA. That's a simple way I used to memorize that. So now cos is adjacent out of hypotenuse. So what does it mean? We check here. This angle is adjacent. 55 is here and it's adjacent to 90. That makes this adjacent out of hypotenuse. Hypotenuse is the slanting one, which is z. Okay. So let's try to get now what is equivalent to that cos 55, which is x out of z. X out of z. From there, let's now look in terms of 35. What will be x out of z? Let us check for sine of 35. Sine of 35 degrees is given by opposite. Sine is opposite hypotenuse. So if you see our 35 is this angle, which is adjacent to 90, that makes this our adjacent, and that the angle is opposite to that side, which is our, so our opposite is x, out of hypotenuse, which is here, that slanting one, which is z. Cos of 35 adjacent becomes this, which is y, out of hypotenuse, which is z. Our tan of 35 degrees is opposite, which is that, that which is x, out of adjacent, which is y. So which one is actually x out of z, which is the same as cos 55? You realize it's sine 35. Okay, so we come here, this also the same as sine cos 55 is the same as sine 55, but negative is there, so you need to consider that sine 35 degrees. So cos of 55 is the same as sine of 35, if you see from that side work, and which our sine 35 has been given as 0.5736. Okay, so we can go to our next number. That's let us look maybe the another category of the numbers. It's number 4. Given that sine theta is given as 7 out of 25, and that theta is an acute angle, find, let's say, A cos theta, B tan theta. Yep. So now we check the solution of those two. A is cos theta. So now we are given sine theta. That means we can actually get cos theta, and we can get we can also get our tan theta. So let's draw a right angle triangle so that we can have an angle here. There is theta. Our adjacent will be this, our opposite will be this, because theta is adjacent to this. That makes that side adjacent. Opposite will be that, because angle is opposite to that, and that's our hypotenuse. So sine theta, which they have given, sine theta equals to opposite from our SOHCAHTOA. That opposite hypotenuse. So it's opposite out of hypotenuse, which we have already the value 7 out of 25. What does it mean? Our opposite is 7 and our hypotenuse is 25. So hypotenuse is 25, opposite is 7. Okay, so how do we get our adjacent? We use Pythagoras theory that hypotenuse squared is the same as this, the side squared, and this side also squared. So we say that let's give that x. So our x squared plus 7 squared will be 25 squared. Our x squared will be 25 squared minus 7 squared. Okay, so 25 squared, you know, is 625. So it's 625 minus 7 squared is 49, and that result will actually be 576. Yeah, x squared is equal to that, then x squared is 576. So x is actually the root of 576, which is, I think, 24. You press that on the calculator, root of 576 is going to be 24 units. So that means our adjacent is 24. Okay, now we go in here, we have our cos theta equals to adjacent out of hypotenuse, which is adjacent is 24 out of hypotenuse 25. Then what of our tan theta? Tan theta is going to be opposite. Our opposite is 7 out of adjacent, which is 24 that we got. And those two are done just like that. So we can go to our next bunch of our question, and that I think we'll mark today. That we'll have covered almost everything that we have introduced under introduction of trigonometrical ratios of acute and obtuse angles. Let's check that. Given that sine theta equals to 24 out of 25 and theta is an obtuse angle, find a cos theta, b tan theta. Now this time we have an obtuse angle. So now we're going to have, let's first draw something that will help us to we check now that, okay. Let us go to that. We r theta, it's an obtuse, theta is obtuse, that means the angle theta is going to measure up to inside there. But these are basic. Even this now, this way it's a best way you can handle such questions. Even here, we are not supposed to simply draw that but that this can also is another method. But the best way is to draw that. Then just know that is an acute angle. You know it lies there, and theta is that angle. You draw and give your sides, and you solve for that. It can be the best way to do that. So this now we are going to. It's better because it helps when it comes to acute angles. You know where something lies, and it can help you to know the signs like we covered before. So now here we need theta is here. What does it mean? That means here is cos. That means here is 180 minus theta. You drop that. We try to complete that. Okay. We have sine theta already given 24 out of 25. But you know that as sine theta from this, okay, sine theta will be the same as if we, sine theta is obtuse, so it's going to be the same sign. But this is our second quadrant since it's obtuse, where we have only sign positive. Remember what I explained before? That means it's positive sign of 180 degrees minus theta. Okay, so that means sine is actually the same as there's no difference there, so we can use that sign. That means even this is given by 24 out of 25, since that's are the same. Okay, now that means we are comfortable. We know that if we are looking at sine of 180 degrees, it's the same as we are looking for sine of that theta, because of the relationship that we had before. So we are actually going to have now, we get from our, we have our opposite, sine is opposite from our secateurs, we get that. Opposite is going to be this, opposite to that. So we have here, opposite is 24, our hypotenuse is 25. What does it mean here? 25 squared. So this plus this square plus this square must give that squared. So that if we give here x squared, x, that means our x squared plus 24 squared is going to be 25 squared. X squared is going to be 25 squared minus 24 squared. What does it mean? That means we are going to have actually, we're going to have angle. That means the adjacent will perhaps become 7. If I see that, if you solve for that, you must get your 7 here, because this 625, and here going to be 24 squared. If you may, it's in the end you're going to come with 49, where you get the root to get 7. So now we are going to have that to be 7. So that means we can get actually cos theta. That means cos theta is going to be now negative, because there cos is negative there in that second quadrant. It's negative cos of 180 degrees minus theta. Okay, whereby our cos is going to be negative, our cos is adjacent, which is the same as negative cos of that. So that means we are just going to attach. We first get our cos theta, which is adjacent out of hypotenuse. Adjacent is 7 out of hypotenuse, which is 25. So we just put that sign 7 out of 25 negative. That's what we have. And so we have, we have cos theta is negative there, so we are going to have that in as a sign. We go to now tan theta. Tan theta is going to be given by opposite is the same as first of negative. Tan is negative in that quadrant. We have 180 minus theta. Okay, but what's our tan theta? tan theta is given by tan theta is given by